All right, we are doing yet another version of this thingamabob here. And let's see if I can do it right this time. All right, here we go. There's the screen. All right, so let me show you what I've been up to. It's funny, Mark Twain once said, joy of editing, of being really concise and to the point and all that is it's way harder to be concise and than to just wing it or to just ramble on and on. So I'll stop rambling on and on. But suffice to say, this is what we're after, and you will facing. But these guys no longer have the arrows, but they certainly do engage. Let me knock them out of the way there, and they are actually a lot more aggressive now, sort of. And I can still sneak up on them if I'm careful. But they don't have that little arrow pointery thingamabob. So you'll also notice that they animate in the direction that they are walking. And whoa. So if they start towards me, they'll start walking that way. And generally, they kind of favor left and right, but they will go up and down depending on how their animation is. And if they totally stop, well, they won't ever totally stop. They kind of momentarily stop, and then they will go idle for a second. They completely stop, and then they'll start walking in another direction. Well, I guess they can be tuned a little bit more. But the idea was to sort of simplify the approach to these little guys, to not use the little spinning arrow for one thing, being the main thing. So for those of you who tuned in last time or snuck in while I was at first Unity screen and not my Visual Studio screen, which was not a good thing. So because you couldn't see my code, and that was bad. And it probably worked out for the best anyway, because I was kind of thrashing around because I was just like, kind of weird. It happens. So let's look at this NPC. This is sort of a new version of the NPC. Like I said, it's a slightly simplified here. Now, it doesn't have that rotating spinning arrow thingamabob, and it has this new script called NPC_WASD, and it's just different. It's not really WASD, to tell you the truth. It was going to be, but now it's not. And what else doesn't it? It doesn't have the basic enemy controller in there anymore. It does have the spritelet default, and this is only a remnant of using the universal render pipeline. Don't worry about that if you're paying attention. Do not worry about that in your versions. So it does have the animator, and the animator, I discovered the one really cool thing I discovered, and I don't know why this didn't occur to me before, is that I can have multiple transitions from one state to another state, and they basically are the same sort of transition. But the cool thing is this solved my OR problem in these conditions, right? So I used 2 transitions to overcome this OR issue. Cool, right? Let me change that so they look a little bit more similar. Let's see, why don't they look exactly the same? Let's get these to look exactly the same. All right, that should be 0. There we go. All right, so this is my OR condition. Basically, I have 2 transitions from any state to the side state. And that means that you will go to this state if this or this is true. So I have an OR. That's the way to do it. It's a little wacky, but basically that's the OR. So it will go to the side state if the x velocity is greater than 0.1, or the side velocity, the x velocity, is less than 0.1. So this solves, or it removes the need for a little bit of logic that we used to have inside of our script. Now we can really just refer to the velocity of the rigid body. You'll see, okay, in here, I'm gonna loosen this up a little bit here. It will turn basically it will go to the idle state if the overall velocity is, is very close to zero. Basically, the x velocity and the y velocity are both within 0.1 plus or minus 0.1 of zero. And that will put it into the idle state. The side state I just showed you, it's going to be basically if there is x velocity or there is in either direction. And the up and down are a little bit special in that they will only go to the up or down if the x velocity is very small and the y velocity is either negative to go down and the y velocity is going up. This way, it sort of favors the side-to-side motion, right? So that if that's not happening, if it's if there is some x velocity, it will tend to do this, which is okay, which I kind of like. There's probably some other things you could do to the logic here as well, but the basic idea is that if there is no x velocity, but there is a negative y direction, negative y velocity, we're going to use our down animation. If there is a positive y velocity and no x velocity, it will be in the up direction. Side will be one of two ways. It will either be the x velocity is greater than 0 or greater than 0.1 or less than negative 0.1. And it'll go to the idle state if it's very close to 0 overall. Okay, so this sets up our animation, our potential animation states. This is our animation state machine. So back in the scene, we're back in the, let's see, here's our NPC here. And we'll click on him again. Once again, he has this WASD script. Okay, NPC WASD script. So let's take a look at that script. Now, the first thing we want to look at is here in the update, this is where we tell the animator what to do. And you'll notice there is really very little logic here in terms of what the animator is going to do. Here's the pieces where we talk to the animator. We say, okay, animator, the x velocity is velocity.x of the rigid body. So we just basically plug in the x velocity of the rigid body to our state machine, our animator state machine's x velocity parameter that we set up. And if we go back over here, let me make sure, for those of you paying attention, we go parameters. We have these two parameters. They are floats. We have an x velocity and a y velocity float there. All right, quick, back to the other one. Try to be quick. All right, so that's where those two get set up. And this way, whatever is going on with our rigid body, its velocity, its x velocity and y velocity, that will be all that is necessary to tell the animator about. Okay, we could tweak it a little bit, but that's basically it. Now, because we have a three-way animation, meaning we only have a side animation, we don't have a left or right animation, we use the fact that a positive velocity, basically a velocity in the x direction that is greater than 0, we use that to flip. It will be pointing one direction. If it's positive, it will then get flipped, right? So we'll set this flip Boolean to be the point in the right direction. And that corresponds to, let's see, go back to the scene. Here is our NPC, and you'll see in the sprite renderer, this flip right here, right? It doesn't do much right here other than flip the shadows, but that's the thing that it does. It flips it. Now, if we were looking at the walk left or right, it would look much cooler. All right, so let's go back to the scene. Now, so that takes care of animation. And if you notice that it works, right? Here, let me just start the game. They are always kind of doing the right thing. And generally, like I said, they sort of prefer the left and right. And that's because they're not moving exactly up or down. Now, if they were moving exactly up or down, sometimes you can see it here. Let's see if I can. If I'm moving exactly up or down, eventually, yikes, I just started moving up. There he is. There's a good example. Wow, they're aggressive. All right. So That's what's going on there. Now, the actual sort of AI, the logic that is going on. And you notice that didn't happen in the update routine. It's happening in the fixed update. Okay. Now, one of the reasons this took me a little bit longer than I had intended is I discovered in this case, there's a little bit, there's sort of a bug, or there's sort of a bug in my logic that this, in this case, it turned out to be more of a bug. In the other case, and the normal with the spinning attention, the spinning reticle that they could aim in, it wasn't as much of an issue. But in this one, it turned out to be more significant. All right. So let's talk about what's going on. Now, what we're going to do here, since we don't have that little spinning arrow to indicate the direction that they're pointing in, we're really just going to use the x velocity, y velocity, the rigid body's velocity to know what direction they're pointing in, right? So if they are, so long as they are moving, that becomes the direction that they're pointing in. Now, if they stop moving, we assume, or we just leave it, we don't change the direction that they were pointing in. So this is vector 2 called attention. And inside a fixed update, so long as there is some magnitude to their velocity, right? So long as there is some magnitude there, we set the attention vector, the way that they're pointing, to this, to the velocity just normalized, right? So it's got a length of 1 and it points in that direction, right? Okay. So we know it's the velocity, it's that vector. All right, then the other piece of information we're interested in is the relationship of this enemy to the hero. From the enemy to the hero. Okay, that's what that is. And this indicates the direction of the ray. That's going to draw a ray of length 10, right? This is normalized. So this is going to draw this length 10 blue ray to say, what is that general area of interest? Okay, so let's pop back over here again. Now, let's not look at the games. So we're going to turn maximize and play off. And we're going to look at the scene. There we go. You'll see that the direction that they are pointing in, that's moving in, is the blue arrow here. So the blue, so it's every time they kind of change or they get a little bit of, oh, that guy, he stopped for a moment there. So as they move, the blue ray kind of indicates where their general attention is. Whoops. All right. Unless he noticed me and gave me a shellacking. Pardon. Okay. So we now have the of information we can use, right? The direction that they're facing in, the vector that they are pointing, that points between the enemy and to the hero. All right, that points that. Now we start off assuming that they are not engaged. They do not see this enemy yet, or the enemy does not see the player, right? So we look at a couple of things. We start to make some decisions. We say first, okay, is the relationship between the two, the vector that points from there to there, is it less than, the magnitude of that, is it less than 15? Meaning, are we 15 world units away? If we are, we assume that they can't see us in the distance, or they mistake us for somebody else or something. They're just not interested. Okay, so they're not interested. If they are within 15 units, then we draw a green line indicating, yes, okay, that's, now we see the relationship. We see that the line from the enemy's position to the hero's position, that hero vector. We see that green vector. Okay, again, we'll come back over here. You'll see these green vectors. All right. There's also the squirrels, I guess. So anyway, green should mean 15, but squirrels are extra. You'll see this lost the attention, right? He moved 15 away. Squirrels show much further. They have a much further attention span. This guy just got the idea, and we'll move away from him. Okay, and then he went back to blue, right? So he's not interested. Okay, we're close enough for him to be interested. All right, pause. Come back over here. They are potentially within earshot or eye shot or whatever. Now, here's where I got a little whack. Do is we want to say, okay, is their attention, are they facing the general direction of the player? right? This H vector is our vector that points from the enemy to the player, and this is the direction in which they are sort of facing. All right, so we do the dot product. We get the dot product in here. I just set it to DP, which is a public variable, public float, just so I could monitor it from the Unity editor if I wanted to. And I compare that to a dot result. Now, remember, if they're perfectly aligned, if they're facing in exactly the same direction, it's going to be 1. If they're perpendicular to one another, the vectors are perpendicular to one another, they're going to be 0. If they're pointing in an opposite direction, they're going to be a negative number. Okay, so it's up to me to, it's basically their peripheral vision. If I want to give them 180 degrees of peripheral vision, that would mean that the dot product is greater than 0. If I want to give them an even wider field of view, I might even make it negative, right? If I said negative 0.25, basically they would have what, like a 2. What that is. It can be anywhere, typically it's going to be about 0 for a 180-degree field of view, right? That means it's, yes, generally in the right direction to be seen or to see them. Okay. Now what we do, now we cast array. Now what I used to do, and this is part of this sort of bug that turned out to be more important in this version. Okay. So now I'm casting array not from the attention, not according to the direction that the enemy is pointing in, but using that hero vector, the actual vector in between the two, right? So at this point, I say, okay, abandon the direction that you're pointing in and assume that the relationship, they are close enough now, they were within range. So now let's see the clean line of sight between a ideal position and between the two, the player and the enemy. Okay, so this is the part where, again, this is the ray is starting from the enemy and it points at the player, right? Not in the direction that the enemy is pointing, because that might miss it now and disregard of all our wonderful peripheral vision stuff. So we want to make sure we don't disregard that. We want to say, all right, let's assume that we now we've turned our heads to look, right? It was our peripheral vision. Now we got our focus on there. So let's look in that direction. And we're going to use a length of 10. So we're going to say, okay, if you're within 10 now, we draw it down just a little bit here. I guess we could make this 10 and that 10 if we wanted to. Or if you weren't as worried about efficiency, you could even eliminate this outside one and just use this one, right? That would actually work. That would work, I think. Anyway, so we've used the dot product. We've used a general, are we close enough? Is it in our peripheral vision? Can we draw a clear line of sight between the two? If that is true, then that's what comes down here. Okay, now we can, well, we're going to try to draw that clear line of sight. That's what this is. Okay, we're trying that clear line of sight. This is if we hit something, then we check to see what is it that we hit. We didn't hit a wall, did we hit rocks, did we hit colliders? No, if we get to here, this is where we say, oh, the hit collider that this raycast returned was the game object associated with that hit collider named hero, right? That's what this is, hit.collider. The question mark is just a check to make sure it's not null, right? If it was null, potentially that would be. We'll go ahead, we'll draw a line just to indicate, yes, red, we are engaged. But the important part is here, we just say, we set engaged equals true. That means, yes, we want to actually attack. We want to go and follow the player now. All right, so that's what this is all about. That was the intelligence part. Okay, pause now, read that. Okay. Okay, you done pausing? All right, now let's look, what do we do if the player and shoot at the player, right? So if we're a certain distance away, if we're more than a certain distance away, we'll chase the player. We don't want to run the player over. That's why this is here, right? We say, okay, chase the player if we're not already close enough. If we're not within 3 units, chase the player down to get to within 3 units of the player. Okay, now how do we do that? How do we chase? I changed this a little bit from the other version, right? So here what I'm doing to chase is I am setting the velocity of the enemy, and it will be affected by objects and crash into things and so on, since I'm modifying the rigid body's velocity, but it's a little, it's a simple way to do it. Say modify the rigid body's velocity to be pointing in the direction of the player, right? There's the hero's position minus the enemy's position. Again, that's sort of that hero vector, normalized times 3. So that gives us a velocity of 3 units per second, something like that, in that direction, right? In the direction of the player and multiplying by 3. Pause there if you want. Digest that, okay? Set the enemy velocity in the player's direction with a magnitude of 3. That's what's happening there. Okay. That's the chase part. Are we going to chase within 3 units? Okay. Now, the next thing says, okay, if we are closer than 10 units, if we are close, you see that happening down here. There we go. If they are close enough. Okay. We're going to shoot every 0.5 seconds if we are close enough. Now, what happens here, a couple of things. It does look at the angle of the attention, the unit that we're facing in. And you know what? This could be tweaked as well, because right now we're going to be pointing in that direction. This could be changed to be the direction, that hero vector, this up here. Right, so it really could be h vector dot, because we're assuming, yes, it's shooting at the player, right? So it could be h vector dot magnitude, all right? So that's going to be the angle, the direction we're going to point in. Whoops, h vector, sorry. That's the angle. And it's going to figure out the angle between... Oh, wait, we do want, that's vector 2, h vector. Oh, what happened there? Normalized. And we're going to figure out the angle between 0, just pointing straight up, and the direction we want to point in, right? That's what we do. We have the signed angle to figure out, okay, how much do we need? Okay, how much do we need to rotate the projectile? Right, that's what it looks right. We want to point the arrow in the direction, right? Okay. Right, is direction towards the player, how much we need to rotate by. And then we go ahead, instantiate it, the projectile, in front of the enemy, right, with the rotation. There we go. Instantiate the projectile in front of, right? It uses a little bit, just scooches it just a little bit in front of that, and then rotates it. Uses the Euler to get the right quaternion rotating in the Z. All right. Then the other thing we do is we set the layer to the NPC layer so that the NPCs can't shoot themselves, right? So we have no conflicting layer there. And then we go ahead and we set the velocity to this is kind of fun. We set the velocity to the velocity of the thing that's moving times 4. So we get sort of a velocity multiplier thing going on there, which is kind of fun. So if he's running towards us, he's going to shoot at us really, really fast. That works out. We decide, okay, it's also going to only last for 3 seconds. Oh. And then we remember the time we fired the last arrow. So next time we're not firing too often. All right. And that's what's going on if we're engaged here. Okay. Now, the pièce de résistance, the important part. Okay. How do the enemies move if they are not engaged by the player? How do they mill about town? How do they go about their business? Okay. That's what happens here. This last and final piece. All right. Else, if you're not engaged, if you're not running after chasing the player and all that kind of stuff, right, you will say, okay, if get component, rigid body 2D, velocity, magnitude is less than 0.1, okay, if it slows down enough, we decide, okay, it should wander off in some other direction, right? It's allowed to move. Once it stops moving, it's allowed to randomly move in another direction. And that's all that happens here. Right? So if it's not moving, we add a force to the enemy, to that player, that will nudge it in a random direction. Right? So that's all it's doing here. It's adding a force, a one-shot deal, because we're not going to do it over and over again. We just want to have a one-shot impulse, force mode 2D. You can either be an impulse or sort of a continuous force or a scaled force. I don't know, scaled according to the fixed update rate. But in this case, we're just going to say, okay, it's one shot deal. That's why it's an impulse. So it's a one shot force in a random direction, right? The force is plus or minus 5 in X, plus or minus 5 in Y, and it's sort of in any direction. So you'll see them kind of randomly nudging themselves around every time they come to a stop. So let's try that again, shall we? I guess I could have just continue, but we'll hit play again. Let's see. What do we do that in about half an hour? That's not too bad. All right. So the enemies are wandering around doing their thing. And I'm using a fairly aggressive, like I said, they're kind of on the aggressive side. I think I gave them a peripheral vision of just 0. I think that's what it was. I think they can see 100. And I'll show you where that is. If we go in here, we look at prefabs. Our NPC prefab. You will see, where's our script? WASD script. Yep. The dot product result is 0. So they have pretty wide peripheral vision. So they're kind of aggressive. And that's it. Okay, 30 minutes to explain the AI, kind of start to finish for the enemy without dealing with the rotators and all that kind of crazy stuff. Right? This is the more basic AI. It's just nudging the AI in whatever direction, and then whatever direction it happens to be moving in, that becomes its direction of interest. Okay. Hopefully that helped. Pause the video, watch it again, go back for key moments if you need to. Take care. Have a great weekend.